All right, we got ourselves a part D that is talking about part C. And it says for the function h defined in part C. Oh, which one? I think they're talking about this one right here. Find all intervals on which h is decreasing. Well, if I want h to be decreasing, I want h prime to be less than 0. So that means I'm going to take the derivative. And that means I'm going to take the derivative here. And then I'm going to set it to be less than 0. All right, well, how do I take the derivative of this one? Well, you might be wondering, what the hell? How do I take the derivative of an integral? Do I use fundamental theorem of calculus? Yeah, you do, but you might want to set it up a little bit where you put the 3 at the bottom, the x at the top, and if you want to be able to switch that like that, you need a negative right here. Okay, so now we're going to take the derivative, and that means that this negative can just kind of come to the outside. And we're going to take the derivative of an integral. So do the derivative and the integral just cancel each other out? Sort of. The fundamental theorem of calculus says that you're going to take this x, you're going to plug it in, and now you're going to have f of x. And of course, we still have that negative from before. But that's it. That is all you have to do. You don't put the dt anymore. It's just negative f of x equals h prime of x. And we want it to be less than 0. And now I could multiply both sides by a negative here. If I do so, that is going to flip the sign whenever you multiply or divide by a negative. So now we just want to figure out when f of x is greater than 0. Well, here's my graph of f. And when is f greater than 0? Well, looks like that's happening between 0 and 2. So I would just say the 0 to 2 interval notation. And that's it. That's it. It says explain your reasoning. I mean, this looks like a pretty good explanation to me. If you want to take a look at the scoring guidelines, it says pretty much all of what I said. So yeah, it turns out if you wanted to just write this, go for it. I like what I wrote. That's how you do it. And now the video's over. So anybody that's still here watching the video, there's really nothing else to watch. Problem's already done. You don't need to watch this part.